Okay, we're recording. Turn my volume down. We are looking at what we were looking at the last video, which is the right foot in front when we stop moving? So we have the example up for, where is it? Let's come here. We're looking at our beam walking because I only check this if we're actually on the beam or not, because Um, it felt really weird to be on a balance beam and not have our feet repositioning themselves depending on which foot was actually and should be in front. So we just changed that position. So you can see here, make this really big so you all can see it. We take a step, and then now our left foot is in front. We take a step and we fall off the beam. Okay, let's get back on. We take a step. Now our right foot is in front, left foot, right foot. Okay, so how are we calculating that? We are saying this function right here. So, like I said, we're checking beam walking first. And if we're not beam walking, then right foot is never in front and we're just not calculating it. So we're doing all of this here to just to figure out if we should set this bool to true or false. And then we say, oh, do we have acceleration? So basically, we want to check these values while we're moving so that we are getting our um, our foot positions relative to our root position on the fly, like at runtime in real time. So the first thing we're doing is I'm just spitting out a few values here for the left and the right foot. So let's come here, shrink this a little bit. We are getting our right foot relative to our root here for x and y. So our x position when our acceleration stops. So, like I said, we're just checking this while it's true. So, while it's true, it's updating every tick. And when we stop, whatever the last value is, that's what this x position will be. So, if we print screen this, just get this value here and set the duration here, and we make it this lovely red orange color here. Let's append, not add. So here, let's say append. Bring that in here, and we're going to say we watch this. And we're going to get back on our beam. Let's fly over there. And we're going to get up there. So while we're moving, oops, I want also this to be here while we're not moving. That way we can see it printed out when we stop moving. We want this value here, right foot position when stop. So get right foot position x when stop. I'm gonna pipe that into there, compile. We are watching this. Our value is 1. We are clamping it, -1 to 1. I don't know why we're clamping it off the top of my head. It's been a while since I've done this code. So -1 when the right foot is in front. And let's get back up there. Oh boy, something's broken. That's game dev for you. Okay. You make a print string change and everything goes haywire. Okay. We are here. getting up. -1, 1, -1. So probably just says, that is weird. It shouldn't be wiggling like that, those feet. So I need to check that too. That one's fine. I guess when I mirror, it's funky. Okay. Because get this right foot in front. To get this right foot in front, I mirror the animation. Okay, so anyway, so what we really want to check is, I think it's the Y position. We need to look at the skeleton. So we're going to look at our foot right. So yeah, we've got our Y. It doesn't make as much sense as I was hoping. So Y forward is, Y positive is backwards. Let's look at the left foot. So that's just the opposite. Okay. Good to know. And then you're also getting the ball of the foot, its Z location. So we're putting that out as our right foot position when Z stop. When stop, Z. So we're clamping our Y. We probably just want to say, are we in front or back? So let's look at that one. Right foot, front. Right foot, stop. Y. There we are. Let's compile that. Now let's look. Okay, our right foot is in back. We're at -1. Whoops, we fell. Can we get back up this time though? No, we're through the beam again. I've done something. Oh, so weird. So I've broken the game somehow when we get on the beam and then we get off the beam. So that's something I'm going to need to figure out. Okay, let's try not to fall off the beam. So -1 when the right foot's back. 1 when the right foot's forward. Now we're at 1 again. Right foot is back. Right foot is forward. Now we're at 1 again. So that value doesn't make any sense to me either. So we're getting these values. The ball Z, I want to say, is our height in relation to the root. So if we're above the root, then we're in the air and we're moving. And then I calculate all that for the left foot as well. Okay. So then, literally, then we look at, in our sequence, the distance from the root and the right foot. We're just picking, get distance between two sockets. We're just using that node. That's just a node. So we're looking at the two sockets, the root and the foot right. So let's print that one out. Right foot distance. Get right foot distance when stop. Oops. Print that. So unfortunately, I haven't been able to figure out which X or Y value is dictating if the foot is in front or not. Okay. So our distance is 33, 34, 50. So we're just spitting out these values. As far as I know. Did that work? Okay, I can jump off. Okay. So now we know where the right foot is in relation to the root. So we're spitting out all those values, our X, our Y, our Z based off our ball. And we're doing the same thing with our left foot. And then we're actually getting the distance we are away from our root bone also. So now we're doing some weird things here. So we're back to our first sequence. We're coming down. First of all, I'm just checking to see if we're on a float or slope or not. So if we are not, then we'll come forward and do these other calculations. If we're not on a slope, this is interesting. So if we're on a slope, we're saying, oh, okay. So if our slope is greater than 0, our ground speed needs to be slow enough to where we'll do this check. And if it isn't slow enough while we're on a slope, and this is just for my game, so I had to come up with these rules because something looked weird. So check if speed is less than slowest upward slope speed. So if that's true, while we're going up, then we'll do this whole, is the right foot in front, is the right foot in back, or not? And if that's true, then we'll come down here and we'll do this step. But then if we look at this false statement, if we're less than 0, so that means we're, so neither one of these is equal to 0. That's interesting. Huh. Check if moving upslope. So if you're not, oh, basically this one would be 0. If we're only checking for greater than 0, then this other one would be 0 or less than 0. Okay, so false is 0 or less than 0. So that makes sense, I guess. It's not if we're moving, this isn't our slope direction, it's just the pitch angle that we're at. Okay, so then we're just checking ground speed. We're saying, are you less than or equal 150 units per second? If so, then we're going to check to see your right foot position when stop Z is greater than 0. So I just need to check to see if the foot is off the ground or not. So that's basically what this is checking. So let's see here. That one I never checked. So right foot Z. Let's get that. Pipe that in. Compile. We're going to look at our number here. Right here. Negative. Remember, this is off the ball of the foot in relation to the root. It's interesting. Well, that would explain why all this stuff was wrong while we were moving. Ugh. Need to go back and recheck it. So if we put this at the end, let's bypass this. We're gonna bring this one over. And we're gonna put this at the end here. There we are. So let's check Z. That's the one. We're checking Z now while we're moving forward and backward. So let's turn around. Actually, before we continue, this beam is really, really, where are we? Over here. Whoops. Let's go up. Let's take this beam and we'll duplicate it and move it to our player start, closer to our player start. And then we will scale it. And then we'll also make sure that we can't fall off. So we'll make it really big. Okay. Now let's play. There's a beam. Getting up. Okay, great. Now we're in beam walking. So we're looking at which value here? We want to look at our watch this value, our Z position in relation to our root. So if we slow-mo this, if I could see you, slow-mo, 0.2. See our foot when it's up. So it's watching the right foot. So it has a positive value when it's up and a negative value when it's planted. So I know that if it's positive, then for the most part, I know it's off the ground and not a planted foot position. So the next thing we want to check is the Y position. So let's bring that over here. Do this all again because I wasn't literally checking it while we were moving, just when we were stopped. And it's more important what's going on while we're moving. So now we're at 1, now we're at -1. So it seems very consistent. So right foot's in front, -1. Right foot's in back, 1. -1, 1, -1 front, 1 back. Okay. And I think I was checking X because, these values, these beams can be in any sort of rotational order that we want them to be in the world. So meaning that they can be rotated all sorts of different ways, and I'm not going to know exactly which way they're going to be rotated. So again, we're saying -1 in front, 1 in back. -1 in front, 1 in back. Okay. So let's come here. We're going to look at this calculate right foot front. So it looks like I've got a calculation for if the left foot is in front also. Okay, so calculate right foot front. So we're just checking our directions here based on our forward vector. Looks like I'm taking our forward vector and I'm saying if we're front, moving forward or backward, moving left or moving right. So depending on if we're moving, oh, this is more than I thought. Okay. It's like I said, it's been a bit. Right foot front. This is also a pretty simple. First off, let's come here. So it looks like we're doing more or less the same thing per direction. We're just checking right foot front X if we're moving right or left. And then we're using right foot front Y if we're moving forward or backward. Okay, so first of all, we're just trying to figure out what is true or false here. So this is interesting. So right foot position when stop Y is greater than 0. So that means that we're going to be behind the root because -1 was in front of the root. Okay, then we're going to check the distance when we're stopped. So how far behind. And we're also going to check the left foot distance when stopped. So we're passing that all through an OR. So on this first one, we're saying the right foot position when stopped y is greater than 1. So let's say if you're greater than 1, that means the root is here and the right foot is back here. So behind, there's the right foot. We're going to be behind the root. So if you're greater than 1, remember -1, so less than 0. I'm sorry, greater than 0. If you're less than 0, that means you're a -1. That means your right foot would be in front of the root. Okay. So now we're checking the distance. And if this distance is greater than the left foot distance when stopped. Okay, so if the right foot distance from the root, so let's say that this is the right foot over here. Here's our root, and we're behind the root. And we're also saying that the right foot, say the left foot is here. So the left foot is closer to the root here, and the right foot is further away from the root here. So that distance is greater. So if you're behind the root and you're of greater distance away from the root than the left foot, then this will be true. Okay. And then the other one is you're greater than, so we're just checking to see if the right foot is behind again. And so you're greater than, so that means the right foot is basically here. So your right foot is less than the distance. So now we're just saying that the right foot is closer to the root in this scenario. So in this one, the right foot is closer to the root, but behind the root. So this is always the right foot is behind the root. And then on this one, we are also saying that the right foot is closer to the root. And then on this one, we're saying the right foot, the right bar, farther. And then this can be true. Okay, got it? Okay, so let's mark that. Let's say right foot behind root, right foot further from root than left foot. And I can't type. Let's copy that. And this one is the same thing, but right foot is closer. So right foot is behind the root, and right foot is closer to root than left foot. On this one, right foot is behind the root, and the right foot is further from the root than the left foot. All right, there we go. Let's save that. So we're checking to see if that is true. If it's false, we come down here and we say the right foot is not in front. Okay. It's interesting that I've got a true value there. So we're just piping it in once. Coming through true and false. We have 2 exits. So I'm not using my true exit here. So if it's false, then we come here and do one more check with the same bool, the same function. Then we say right foot position when stop Y is greater than 0. So same thing. So we're behind the foot. Right foot position when stop Z is less than 0. So that means we're on the ground. Oh, we're not using that one. Oh, we're using this one. Whoops. We're going to say this one is behind root. Right foot behind root. Got it. So let's delete this, this. Is the left foot moving forward but not planted? Left foot in front of right, in front of root, left foot off the ground. Okay, we're not using this. Let's not confuse ourselves. Left foot position when stop Y is greater than 0. So we need that to be not true. Now left foot position when stop Z is greater than 0. So we're checking to see if it's planted or not. And we need that to be not true. And if all of that is together true, then we're setting our right foot root is true. So let's compile. Let's watch this graph, see what's happening. Let's try to get. Oh, is this all when we're stopped? So we're here in this graph. Okay, so none of this is calculating yet. It all calculates when we stop. Okay. So we're not on a slope. Our speed is less than or equal to 0. Our right foot position when stopped. Let's put this up. So it seems like when our left foot ends up in front and we're passing through here, and we're calculating if the left foot is in front. So we're doing a check on the left foot the same way we were doing a check on the right foot. And if the left foot is in front, we're just doing the opposite. Okay. We're setting our right foot bool to be false or true, depending on those two scenarios. Okay. So let's see here. So our left foot is in front. Move this down. Now our right foot's in front. So we're here. Right foot position when stop Z is greater than 0. Sometimes it does mess up. But I know when I was testing this, I was like, well, I'll take that mess up for all the times it works properly. Then I'll somehow fix that bug. All right, so the left foot is in front, then this one takes over. Right foot position when stop Z is greater than 0. So basically, was the right foot in the air? If that's true, let me see. Interesting. If the right foot was in the air, then it's using that top one to calculate it. But like you see, I'm tapping. It's not, just depends on which one we're doing. So it doesn't matter. Okay, so these are both basically doing the same thing. And it's just saying which foot was in the air when we stopped. And then we're checking, and we're really checking. I know we're checking here for Z position, but we're really just checking our Y position or X position in relative to the root, and relative to also where the foot was. So I don't think we actually use this one because you can't strafe, you can't technically move backward while you're being walking, but you can move left and you can move right. So I know I'm not going in like strict detail here. It is kind of complicated, and it's been a while since I've looked at it, so you'll have to accept my apologies there. But we're basically just saying, is our right foot closer to our root, yes or no, than our left foot? And then we're asking ourselves, is the right foot moving forward but not planted? Left foot in front of the root, left foot off the ground. So those are not happening. So basically we're saying, check to see if the left foot is not in front of the root and not off the ground. As long as you're not in front of the root and not off the ground, that means you're behind the root. So are you also behind the root? So are is left foot behind the root and planted? So is the left foot behind the root and planted? And if that's true, is the right foot behind the root? Because if we check here, just to double check, oops, I'm going to come back here. We're going to check our Y position here and here. So that's -1. -1. So every time it's in front of the root, it's a -1. This time it's behind the root, and it's a -1. I do find that interesting. Maybe that's why some of these values don't work sometimes. Now we'd be using X and Y there if I'm using my right and left keybinds A and D. Okay. Yeah, this was kind of a complicated system I wrote, and I'll have to check it again. But I hope that helps. So basically, we're using these values here, to understand where we are in relation to the root. So for our left and right foots, and then we're figuring out which button press we're pressing. So if we're pressing forward or backward or left and right. If we're pressing forward or backward, we're using our Y positions. for our right and left foots. And if we're pressing left or right, we're using our X positions for our right and left foot. But then we're always using our Z position to figure out if we're off the ground or not. At some point here, left foot Z. And then we're just saying if this is false, then we're just doing one more check. If we're behind the left foot, so either one of these is false. So that means that if the right foot is behind the root, it kind of doesn't matter at that point. But we're also saying if we're now checking, oops, this is not behind the root. This is, yeah, that's behind the root. Because a negative value was behind the root. So now we're checking, are you behind the root again? But is this left foot not moving forward? So if that's false, then we're setting the right foot as false here. But if that's false, we're doing one more check. And if this is true, then we'll set the right foot as true here, as it's in the front. So yeah, it's just basically like, where is the foot in the cycle at any given moment is what we're trying to figure out. So if we're saying right foot's moving and the left foot is planted and moving backwards, then if the root is here and the right foot is still behind the root, and say it's here, and the left foot was, let's undo that one, and the left foot was still here in front of the root, then the left foot's going to be in front. So that's basically what we're checking here. But if we're saying the root's here, the left foot is here, and the right foot is, say, off the ground and moving forward like that through the air, and it's in front of the root, then the right foot is forward. So check that bool to be true. Is right foot forward? Yes, true. Okay. That's basically what we're checking here. And that's basically what this is doing. And we're doing versions of that for moving backward. So we're just taking our negative values there because you're moving in the opposite direction. And then we're doing right. So we're just using X, same things, same checks. And then for left, we're doing the opposite of X value. So we're just negating that here, doing the same checks. And then we've got a right foot, or I'm sorry, we've got our left foot version too. So we're just checking the left foot also. So if the right foot was in the air, essentially, we're going to, here it is right foot in the air. Is left foot in the air. Okay, so if the right foot's in the air, then we're checking it here. Is the right foot in a position that's good for planting? Is the left foot in the air? Is that in a position that's good for planting and being the forward foot position? And we're doing our checks. Left foot gets our Y position, so we basically have reversed everything. So if we were checking the left foot before, now we're checking the right foot. And we reversed our bools here also. We're saying left foot is front, false. And then one more check, left foot front, false, or not. So if that's true, then no, the right foot is not in front. But if it's false, then the right foot is in front. So we're just doing like multiple checks here. First, we check this one, then we check this one. Okay, that was convoluted, and hopefully there's some understanding there. If you guys need me to dive into it a little bit more, I can, to be more specific about it. I haven't looked at this in a while, so I'm kind of just doing this off the cuff. Wanted to run through it though, because our stops are about whether or not we want to do, and I don't, but how would you check to see which foot is in front based off a stop at runtime, and say you didn't want to do a bunch of anim curves or anything like that. Anyway, hopefully that helps or confuses you. Um, and if it does, just ping me in the comments and let me know. And I'll go back and I'll go over the certain sections that you're kind of confused on, and I'll try to explain it a little bit better. Anyway, happy animating out there. Best of luck to you and enjoy the journey.